All right, now comes the fun. I've got to analyze this map to see if people who are upstream in City Fatima, like people up here, if they're washing clothes in the river and using detergents and soaps, where is that pollution going to flow and how's it going to impact people living downstream, drinking water, groundwater, and agriculture along these banks here. So we have the DEM information here in the map. You can see here, I'll turn it on. So there it is, and that gives you an idea of what the terrain looks like. So there's our little area there. And so I'm using ChatGPT because this is the first time I've ever done anything like this. I haven't taken a class. I'm autodidactic, so I'm teaching myself. So what does Chat suggest we do? Chat says, prepare your data, make sure the DEM data or TIFF files loaded in your map view it should be directed onto a local coordinate system. I think it is, but reproject it using Project Raster tool. Let's try it without that. Fill sinks. Before running hydrological tools, fill in any small sinks, depressions in DEM data that could disrupt the flow of water. So go to Analysis tab. It's like Tools, search for fill, and use that. All right, so, excuse me, it's late. So I've selected this, and I'm going to go to Analysis and go to Tools, and then I'm going to go to Fill. Fills in sinks to remove small imperfections. Fill gaps. I think that's what it said. Fill sinks. Okay, so we're going to go to Fill Sinks and see. Try that out. Fill sinks. Sink. Fills sinks. So just fills sinks. I guess that's what I want. And the input surface raster is the corrected SRTM. And the output would be fill. That's fine. Imagine it's going to go to the same folder, GIS photos. And I'm going to hit run. See what happens. So it's calculating and it's running. I didn't put in a Z limit. So I guess that's what it came up with. So that's the fill, and this is with it unfilled. So I hope that works. I'll take off the other one, corrected one. I guess we'll just be using this one here. All right. So that's what we got. That's the fill. And then maybe I need to find my trees map and zoom to the layer to make sure I'm there. Yeah, so that's the area that I'm concerned about. All right, so maybe that should go behind. And now what? Now what is flow direction? The flow direction tool calculates the direction water will flow out of each cell in the DEM, or digital elevation map. Open geoprocessing and search for flow direction. Set input flow to the filled DEM. And choose the default flow model D8. Run the tool. Okay. Each cell is assigned a value. All right, let's give that a try. So we're going to go to take that out, and we're going to do flow. Flow length, flow distance. Chat suggests flow direction. So flow direction is here. Input surface raster will be the fill And the output flow direction is flow direction, fill 1. Now what about, it says D8, I guess that's right, output drop raster. I don't know what that is. I'm going to ask before that, when I run flow direction, should I check output drop raster? Or should I select an output drop raster? Select an output drop raster. Don't know what that means. And should I check the box for force all edge cells to flow outward? Whoa, 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 whoa. What just happened here? Force all edge cells to what? To flow outward. It's like having a private tutor, isn't it? Great questions. An explanation. The output drop raster is not necessarily most flow direction in specific cases. What is it? According to the steepness of the flow to each cell, calculate the drop in elevation to the steepest now and slope neighbor, normalize. When to use it? Use it if you need to know how steep the terrain is at every point, how fast the water pollutes by flowing, but it's not required for a basic hydrological flow direction analysis. So we won't do it for now. For now, unless you specifically need this, you can leave this unchecked. This option is relevant if you have concerns about edge effects in your data, which can affect how water flows near the borders of your raster. All the cells along will automatically first to flow outward, which prevents water from being trapped at the boundaries of the raster. It's useful in cases where your study area isn't large enough to capture the true flow patterns beyond the edges. If you're only interested in internal hydrology and your team extends well beyond the area of interest, like covering the entire watershed, you can leave this unchecked. If it's small and you're worried about boundary effects, it's a good idea to check this box. Output drop raster, leave it unchecked. Force all if you're working in a relatively small area. It's a good idea to check this. All right, I think I will check it. So I'm going to check force all edge cells flow out, and I'm going to run. Fascinating how all this works, isn't it? Oh my. Okay. Ain't that pretty? Looky there. So, here's our area. Well, what does it mean? Well, we will see. It's just values, but we don't know what those values necessarily mean. So, now we did that. Calculate the accumulation of flow, water, and potential. All right, first, I need to know what do the colors in flow direction represent. What is pink relative to blue? It's just like having a teacher sitting right next to you. It's pretty cool. Flow direction, colors represent the direction of water flow. Okay. South, southwest. Color scheme depends on your software's display. That's like symbology. All right, so flowing east, flowing southwest. Therefore, values. So 1 is 8 values. So we have unique values, classify. So this symbology, I see that, but so this dark blue here, 64, means flowing north, really? I'll get to that later, because it doesn't really matter. Well, I guess it does matter. I mean, which direction going north? Most of these things you would think would be going south on this map, but you never know. It looks like, if that analysis is true, that we have these bands during which it is flowing southeast, which would be in this direction. And that's fascinating. Let's just keep seeing what it recommends we do. So after we've run the flow direction, calculate the accumulation of flow, water and potential pollutants from upstream cells to downstream cells, which is where it collects and where pollutants might accumulate. The geoprocessing pane secure flow configurations at the input for the flow direction, leave the default settings and run the tool. And they'll show areas of high accumulation. So we're going to go to flow accumulation. Here, say flow accumulation. There it is. All right, so flow accumulation. Flow direction raster is flow FADMA. So fill CD FADMA. This is corrected. Where's my flow? Flow direction. There it is. All right, so flow accumulation is going to run. Leave these output data and just run it. Good old mathematics is being processed so that we can visualize how the flows go. There's the flow accumulation. What does it tell us? Hell, I don't know. Did an invert, it would be like that, but that's the overt. The overt invert, that's cute. All right, well, what do you want to do now? To visualize it explicitly, you can create a stream network by applying a threshold to the flow accumulation raster. Choose a value above which you consider the flow strong enough to form a stream. In the geoprocessing pane, well, let me do this, and I hope I have enough image for this, but this is what I get after step 4, flow accumulation. I can't interpret it. It all looks black. It's amazing that we have machines that will look at pictures and help them. Results in highlight cells. Try switching from percent clip to minimum maximum. Alright, so choose symbology, which I did. Hit stretch. And so what's amazing is I'm sitting here and doing this with no instruction, and rather than following tutorials and learning the basics, I have a goal in mind. I want to learn how to analyze this problem of pollution going downstream. And so my tutor, which is ChatGPT, is just following along with me and helping me do the steps to get where I want to get. So that means I'm missing a lot of basic ground information, but I'm doing a targeted application, so it feels better. So I'm going to go to change the symbology type, stretch type, the color scheme and stretch type. For stretch type, try switching from percent clip to minimum, maximum, or standard deviation. So from percent clip to I'll try standard deviation. All right, and what would minimum maximum look like? Not as fun. All right, so we'll go standard deviation because you can actually see some of the rivers. And what then? Just in the statistics section, see the min-max value is 0.5 million. Manually set the maximum to a lower number to reveal smaller accumulations. So 1,000 or 5,000 instead of 5.28 million. So set it. So that's the minimum maximum. So statistics, minimum maximum, yeah, is like 5 million. So it won't let me in there though. Value, label. Maybe I need to do min max. Still won't let me do it. So is that the user customized? I can't, won't let me set the maximum value to I need to change from data set to custom or DRA or custom, from data set to DRA or custom. Manipulation I need to make so it isn't grayed out. Switch dynamic range or custom. Okay. Let's do anything. So let's go custom and set this max to 5,000. Oh, much better, isn't it? All right. Okay. Now, I now see what look like rivers and streams in white, and the rest is black. What do the colors indicate? Is normally white is higher and black is lower in a DEM, right? So why do rivers show up white here, like spider webs? Let's break this down. Why are they showing up white? Earlier, it's definitely based on the number of cells draining in. White areas, high flow accumulation. High flow accumulation, meaning a large number of surrounding cells draining in the surface choose pure white and receive water from a large catchment area. Black areas represent locations with low flow accumulation, such as hills, ridges, and flat areas that don't accumulate water. Okay, why does white represent rivers? The opposite would expect from a DEM, where white typically represents higher elevation. In the case of flow accumulation, however, white signifies higher accumulation of water, not necessarily higher elevation. Okay, in DEM, this color shows based on altitude, with white usually the highest elevations. In flow, it's the white number of contributing cells, with white is the higher number of contributing cells. Flow. White in your flow indicates high flow, meaning your cells are draining. Black indicates low flow. It does. Okay. Good. Then the next step is we've done flow accumulation. We need stream network. To visualize the stream network explicitly, you create a stream network by applying the threshold, the flow accumulation raster. Choose a value above which you consider flow stronger proceeding. Geoprocessing, search for con. Set the input to the flow accumulation raster. Okay, so go here in geoprocessing and search for con. Spatial analysis tool. Is it spatial or is it image? Conditional tool. Must be a raster. Right? Conditional if-else evaluation on each of the input cells. So I guess what? Con. Right. Input the conditional raster. Flow accumulation flow. Where value greater than threshold. So type value is equal to threshold. I didn't do anything there. Look at that. Where value is greater than threshold. So that could be a value. So you don't want to put that there. So this is greater than. And then we want to say 500, for example. And 500. Select the output values to 1 where the condition is met, and no data elsewhere. All right, so 1 where the condition is met. So set it to input true raster, close. Condition raster. What? Yes. Experiment get rid. Set the output values to 1 and no data. Yeah, but there's no and there. Intrude 1. False is no data. Well then, no data. Right? Run it. Oh. No data does not exist. So what's that supposed to be? No data? Alright, whatever. Oh, okay. That's that. Let's see what we do if we get to 100. It's like dots. Thousand. Oh yeah. Well, I don't really know what that means. I'll just keep it. I'll move on because it was optional. Watershed delineation. Now delineate the watershed areas which will help you identify where pollutants might come from. Use the pour points where water accumulates. Villages or key points in the river. First, create your points. Right, then use accumulation values to define these points. Use the watershed tool. Alright, well, I'm going to delineate the watershed areas. Use the pour points. Create pour points. Manually place pour points in areas of interest. Use flow accumulation values to define these points. Add data feature class. Add data. How are we going to add data? New feature class. And I'll probably use pour points. And they'll be points. And I'll say next. It's called washing station. I'm gonna make this true false. That would be 4 points. Anyway, I'm not sure. I'm just winging it after all. And it's not letting me do anything. And I don't know why. Maybe because I need to go to edit and I need to save. No, it's not that. Everything is saved. Why is it not letting me finish? Something's gone wrong. 4 points. That should be letting me put a point in there. Won't let me. Huh. Why not? I got trees. you'd think I could add another feature class. Should be able to. Now the finish button comes up for whatever reason. Field, short integer, let's call that ID, and then change this. That should be field washing station, something like that. Agriculture, I don't know, add something like that, but it will let me finish this now. I got a feature class called Pour Points, and I'm allowed now to go in here and go to edit. No, it should be create. There it is, create. I create the pour point. Then when I come in downstream here, and I really need to turn off flow and the flow data and the lower valley diff. Alright, so my flow points are somebody pouring here and pouring there, and I want to get somebody pouring water here and there and there and there and there. I'll make those my pour points, and from pour points I want to go into symbology because those stink, and I want to make these really big, like maybe 15. And since it looks like fabulosa, those will be my pour points over there. All right. So those are my pour points. And what am I supposed to do with those? Go for villages and key points in the river. Create your pour points. Manipulate the areas of interest. Useful accumulation values. Create your pour points. Add data feature class. Digitize points over areas of high flow concentration. I don't know. So just my watershed areas. Use the watershed tool. Search for watersheds. Let me go back here and turn on everything. That's my flow model. Flow accumulation. And I see. So it looks like most of it's where it's really white is where it's going to come to. And I had that con flow, whatever that did. Contrast. Guess that eliminates some of the and then flow directions underneath that. Alright. So what I'm doing now, looks like, is I am going back to analysis, going back to tools, and I'm going to use the watershed tool. Input flow direction to the flow direction raster. Input pour point as your pour points. Okay, run the tool. Okay, in that case, this is going to be watershed. All right. What did it say about watershed? Determines contributing area above a set of cells in a raster. All right. So the flow direction raster is flow direction. Fill, river valley, upper stream, lower valley, flow direction. I guess that's the only one. Then the input raster for the flow points are pour points. Okay. Flow point field. ID, I guess. Watershed flow. and hit run. Failed. Why? Watershed failed. I wonder why it failed. Point field, maybe the ID, maybe the object ID. What does that say? Watershed flow exists. It will be overwritten. Is that what it was saying there? Fine. Maybe locked by another application. Invalid parameters. We can try to create another one. Nope. Doesn't like that. Okay, watershed failed. Maybe they're not snapped correctly. Snap 4 points though. Snap 4 point tool. Adjust your 4 points to highest flow accumulation. Alright, snap 4 point tool. Yeah, well, okay. So, snap 4 points. Alright, where's the snap? Snap 4 points, huh? Okay. That would be under snap 4 point. Alright. Input of the 4 points. Accumulation. Snap 4 point. Alright. Snap 4 point failed. Oh. You don't like it. So what is it saying? It's saying that the highest flow accumulation cells. So it's really supposed to be in the highest places, and they're not. So maybe what I need to do is go to my PowerPoints and edit them and move them so that each of them is in an area of high flow. I don't know what I'm doing here, but I'm guessing. And this in here, because those are the areas of high flow. Okay. And if that's the case, and then we stop editing, we save that, and then we go and we try to do the watershed again. Watershed. Right. Flow direction raster is the flow direction. Input raster for the pour points is that. Pour point field could be that, and then the watershed flow 3. And it failed. All right, well, I don't know what I'm doing in that case. But that said, let's see if I can be visualizing anything. So, didn't work. But here, once you have flow accumulation and watershed, you can bring these. I don't even have a stream network, do I? I will do blue, okay. Bring these in your 3D scene. They're just flow accumulation. Watch them. Style the layers. We don't have. So we go into the scene, and we add to the scene. We add the flow direction. Wow. In that case, probably want to do raster layer and try to bring these down to about 40%. And then we can see the directions. But of course, it does kind of make sense if the green would be flowing north. So let's see what that was. If we go back to the color thing. And we asked it, so green, I have to know what number it is too. So symbology. So green is 32, and 32 is flowing northwest. 32 is flowing northwest. That is right there, flowing northwest. And 64, which is pink, I should put that in somehow. Can I do that? I don't know. And 1 and 2. I should be able to edit this and add something into the value. 8 values, label. Can I open this? Is it a table? What is it I want to do in here? I want to get to data? No. I want to see view the metadata? No, it's not what I want. I want to get into 2D layers. I want to get to symbology, but I'm in symbology. I go to attribute table, then it just says one. Okay, so I need to add a new, not a new row, I need to add a new column. So, sort fields. How do I add? Don't want a new row. Add, maybe it's here. Add unlisted values. I want that. Add all values. I don't want to do that. More. Remove all count symbols. Sort by. Surely let me. How do you add a column? How do I add a column? How do I add a column to the flow direction? Tables so I can put in those directions you gave me. The contents, great. Click on the table options menu. Add field. Really? I don't see any options. Fields. So, object ID. I could put that, I can put in flow direction. And it can be, yes, the data type would be a text. And then, I can close that. Save button is currently disabled, so do that. Now the flow direction is there. Alright, so, save. And now, flow direction. So 1 is, it's pretty cool. One is flowing east. And flowing east, right? 2 is flowing southwest. 3 is flowing south. 4 is southwest. 5 is flowing, 16 rather. 16 is flowing west. And 32 is northwest. And 64 is north. Oh, oops. North. And finally flowing northeast. Alright. So, what do we have here? I save. I need to save. Edit. Save. Right. What do I see here? I see that obviously the pink number 2 is the darker pink, and that is flowing southeast, which is true. And then this number 4 here looks like it's flowing southwest. And that is. And then the brown, number 8, is flowing southwest. Yes, go west, young man. Look at that. It is flowing southwest. The green one is flowing east. That's a good way to tell directions. That's really cool. 32 is that part flowing to the north. It's flowing northwest, so that tells us how to orient this. And then flowing north is 64, which is pink. That's flowing north, and then flowing northeast finally is a darker green, so it's flowing that'd be northeast going that way. So that's really cool. That's really worth getting a picture of. Oh, wait a minute. Do I still have one there? Yeah. Oh, I saved this, didn't I? No, maybe I didn't. Save as, I don't know what this is. It's flow accumulation. Now, cool landscape. This is flow direction. Okay. So that is really, really neat. That you can see all that and then, get down into that there. And right. That's worth another picture. Flow direction 2. All right, so we're visualizing that data. Now, if we put on here our flow accumulation, then what do we get? Flow accumulation in 3D. Ooh. Right, we didn't like that at all. Although the white would suggest, and let me transparentize this. Those white spots, what do they mean? It's just stuff is accumulating? I don't think so. So that's kind of awful. But what about our flow, our conflow? Yeah. What of it? What's the deal with the conflow? Oh, we made it green. So where the stuff is flowing to is down into these stream things. So I guess that tells us something, the conflow, but it doesn't tell us the watershed. But what if we make this a really darkish color? Freakish darkish. Like that. Nah, you don't see it as well. So it's almost like yellow would be yucky. Although that kind of looks like Toxic Avenger. So there is something cool about that, because you can really see it, where the flows and the drainages go. I think it's too much, so maybe I'll go like that and make it the iridescent green. Yeah. Certainly shows you where the flows are. And oh, and of course it should be, I got turned around here. The real map is this way in terms of north and south. Oh, and they even have those values, which is cool. But all right, so that is the flow. All right. Save. And that is the flow accumulation. And I'll just have to learn at some other point how to do the watershed, because that's not working for me. But that is basically then how you go about this. And so my original thing then, there was visualizing in 3D. So what was I unable to do? Stream network failed for me, and watershed delineation failed for me because I couldn't get the pour points. So like point geometry I did. Digitize points over areas of fly accumulation. I don't know what I mean by digitize points. I can ask. I'll ask here. Oh, I've hit the limit. Maybe it's still no. What did you mean by points? Was there some procedure I had to do to digitize pour points? I won't even let me. It says I'm out. I'm the free version. Oh, what was this? It did answer it. No, there's how to add a column. Define the new field. I did that. Okay, well, that's all we can do for now because I'm out of ChatGPT, but I think we've gotten some interesting results for the 3D here. And if we look at this in terms of the flow direction fill, we do see some interesting material there. We also see the flow direction, so that's kind of cool. Maybe worth taking a picture of. So that's our valley. And we'll just grab a picture of that. And we'll save that as watershed. And then when we go to save this, and then we go to our go from here to our documents, and then go in here. We can start to put in some of the information that we have. And then we say, okay, below is an attempt to do spatial analysis using the hydrology tools. We'll say geoprocessing hydrology tools, and then let us insert image from the computer. And let's see if I go here to the details and the date, then we have these images up to here, and we add them in. Yeah. Pretty cool. All right. Thanks so much. We'll see you in the movies.